Good evening, everybody. I hope you're having a wonderful day. Today we're going to be doing some derivatives. So let's first start off with the derivative of x. So we have this, right? The derivative of x. Now, what you want to do is you want to take this, there's an imaginary 1 here on the x, bring that 1 down, and then minus 1. So it looks like this. So you have 1 coming down and minus that by 1. So this would be 1 times x, which is just x, and then x to the 1 minus 1, which would be 0. So x to the 0 is 1, so this would be equal to 1. That's how simple a derivative is. Now let's do another one. So the derivative with respect to x for x squared. So bring the 2 down, and then 2 minus 1 is 1, so it would be 2x, right? Next one, well that's an x, not a y, but that's an x. Another one would be the derivative of x to the third. So just bring the 3 down, right? Bring the 3 down. Sorry about that. Bring the 3 down and then minus 1. So that would be 3x squared, right? Very simple. Okay, let's do something harder. What's the derivative of sine x? So this you just have to basically memorize. So the derivative of sine x is just cosine x. That's just something you have to memorize. And there it is. Cosine. Now let's do the derivative of cosine x. So with this one you also memorize the derivative of cosine x is equal to negative sine x. Alright. Oops, there it is. And then let's do the derivative of x squared times sine x. So this is much harder because you now have 2 things here. If you can see that right there. Yeah. Now you got to do product rule. So you do first this derivative here. So do the derivative of x squared, which is 2x, right? So that's equal to 2x times. Now you want to times that by just the sine x. So this is called the product rule. So f prime, this, times g, which is sine. So times g plus, that's the product rule, plus f, so the x squared, remember, is f. So f, and then g prime, derivative of sine is cosine, we went over that. So it would be 2x times cosine x, right? And that's the derivative for x squared times sine x. And you can take out the 2x, and you know, that would be nice, but you don't want to do that. Now let's do the derivative of ln x. So this is different. The ln x is a little bit different. So what you want to do is take the derivative of the x. So you have there, so the derivative of x is 1, and then put whatever is in there in the denominator. So it'll be 1 over x. So 1 over x. Does that make sense? Okay. Now let's do the derivative of, let's see, of tangent x. So that one would have to be 1 over 1 plus x squared. That's just something you have to memorize. The derivative of tangent x equals 1 over 1 plus x squared. So, and you might want to just check me on that real quick to make sure that's correct. But I believe that's right. So now we're going to do some calculus 2. So let's do some calculus 2. Let's say you have an integral, right? So the integral of x dx. So this is just the opposite of a derivative. So instead of bringing it down and minusing, you're going to plus it. So you're going to do 1, x to the 1 plus 1 is x squared, and bring the 2 in the denominator. So throw the 2 under. So this is equal to x squared over 2 plus c. Don't forget that plus c. Your teacher will take off a lot. Well, not a lot, but we'll take off points for that. And now let's do another one. The integral of x squared dx is equal to what? If you said x to the third over 3 plus c, you're right, because you do 2 plus 1 is 3 over 3 plus c. That's simple. Now, let's do the integral of sine x dx. So now we're going to work backwards. So you remember the derivative of sine x is cosine. Now we're doing the integral, so now we're doing the opposite. So the derivative of sine is cosine, integral of sine is negative cosine. So it equals negative cosine x plus c. That's how simple it is. Now, let's not make calculus difficult. Let's do a limit now. So you got the limit as x approaches 0 of x over x squared. So this is what you have, right? And you're like, oh no, if I plug in zeros there, I get 0 over 0. So that means you can do L'Hopital's rule. So that means take the derivative top and bottom. So the limit as x approaches 0 of 1 over 2x. Notice, now you plug in the 0, you still get undefined. So this does not exist, this limit. So does not exist. Okay? And let's do another problem. Let's do the limit of x approaches 3, and it's x squared. So we have this. This is really easy. You should know how to do this. So that's it. Just plug in the 3. So that's 9. You're done. Equals 9. So now let's do another one. Let's say you have the limit as x approaches infinity of 1 over e to the x. This also you should know. So plug in the infinity, and as it goes into infinity, that goes to 0, right? So that would be equal to 0. Now let's do the limit as x approaches infinity, x over e to the x. Here, you can do L'Hopital's rule, or just know that e to the x goes much higher to infinity than just x, so this would also be equal to 0. But just to show L'Hopital's rule works, the limit as x approaches infinity of 1 over e to the x, because the derivative of e to the x is e to the x. Let me write that down just in case you didn't know. Derivative of e to the x is equal to e to the x. It's the easiest derivative, I believe. Right there on the top. So now this limit is equal to 1 over e to the x, which we said is 0, because e to the x keeps getting bigger, and you have 1 over a big number goes to 0. Now another thing you want to know, let's do the partial derivatives. This is calculus 3 now. So the partial derivative with respect to x of 2xy. So if you're in calculus 3, you should know this. So you're just taking it with respect to x here. So that means you treat y as a constant, so it would be 2y, right? Treat y as a constant. So, like that. Now let's do the partial with respect to y. So partial with respect to y of 2x y squared. Now we're taking the partial with respect to y. So that means we treat x as a constant. So what would that be? If you said 4xy, you're right. So that's 4xy. Right? So 4xy there. Now let's do another limit. So you have the limit as x goes to infinity of 1 over x. Now if you're in calculus 1, you should know this. This is very easy. Up here, plug in the infinity of 1 over infinity, which is 0. Right? That's easy. Now let's do a more complicated expression. This time we're going to use the conjugate. If you don't remember what the conjugate is, I'll show you what it is. So the conjugate, let's say you have the limit as x approaches 2 of x squared plus 1 over, let's say, x, right? Now, here you can just do L'Hopital's rule, right? Just do derivative top 2x, derivative bottom would just be 1 and plug in the number. But let's just do the conjugate to show that it works. So the conjugate of x squared plus 1 is just x squared minus 1. So let's times that on the top and bottom. Now this, you don't want to do this way. It's the slowest way, but I'm just showing you it works. So that's equal to the limit as x approaches 2 of x to the 4 minus 1, right? Because you have x squared times x squared, x to the 4th, x squared minus is minus, the positive cancel, minus 1. On the bottom you would have x to the 3rd, right, minus x. So x to the 3rd minus x. So you have this. Now you're like, how does that help? That's a good question. Now that I think about it, how about we, this is actually a good example of what not to do. If you have something like this, don't do the conjugate. Don't do what I just did. There are times you want to do the conjugate. I think I thought of one, but if you have this, don't do the conjugate. Because see, look, this doesn't help us at all. No help. Take out an x, factor it out, doesn't cancel with any x on top. No, don't do this, okay? This is where you want to do L'Hopital's rule. So x squared plus 1 over x, do the derivative. X squared is 2x. And then over 1, right? That's what I was talking about in the beginning. So now plug in the 2. So it'll be 2 times 2 is 4. That's the limit. Now let me show you where you actually could use the conjugate, or you could use L'Hopital's rule also. It's your choice. Let's say you have the square root of h plus 1 over h. The limit as h approaches 1. Now this one is up to you. You have that ugly thing, right? You can do L'Hopital's rule, or no, you can't actually. If you think about it, you can't. You plug in the 1. Oh no, this has to be a 0, or you could just plug in the 1. That'd be so easy. So there we go. Much better. Now, if you plug in 0, you don't get 0 over 0, you get 2 over 0. So L'Hopital's rule doesn't apply, because it must be indeterminate, which means 0 over 0. You have to do the conjugate in this case. If your teacher says otherwise, I don't know that, but I'm just going by what I know. So conjugate here. Can't do L'Hopital's because it's not 0 over 0. All right? Good. So let's do that. Square root of h plus 1 minus 1 over square root of h plus 1 minus 1. Right? That's just 1. We're just timesing it top and bottom. Basic algebra. So you have the limit as h approaches 0 of h plus 1 minus 1 over h square root h plus 1 minus 1 h. So here's what you have now, right? 1 minus 1 is 0, right? And then factor out the h, okay? Don't forget to factor out the h. And don't get sloppy with notation. Now's not the time. Your teacher can take off the notation. Don't forget the limit as h approaches 0 of h over h. Oh wait, I forgot something. I need the parentheses, right? Parentheses plus minus 1. So parenthesis minus 1, right? That's the same thing. I have h here. Took out the h here. Now the h is over here. That's minus 1. That's good. See the h's cancel here? So that's equal to the limit as h approaches 0 of 1 over square root of h plus 1 minus 1. Now here's a special case I wasn't looking forward to. See, look at that. Now if you plug in the 0, guess what you get? You get 1 minus 1, the bottom is 0. So this one actually would have to be one that does not exist. We did the conjugate, it didn't work. Can't do L'Hopital's, it's not 0 over 0. This would have to be does not exist. There's nothing, we did the conjugate, there's no other option we can do. If you can think of one, wonderful, but this one has to be does not exist. Does that make sense? I hope it does. So it does not exist, DNE. Let's do another one. Let's do the limit as x approaches 5. Now hopefully this one worked. H plus 1 minus 2 over square root of h plus 1 minus 2. Here's a similar one. Oh, let's get rid of the bottom one. That's not a good one. Let's just do x. Oh, this should be x. Oh, also when you do math, make sure you use pencil, not like pen how I'm using. This is just because it's sloppy work, but like when you're doing your work, use pencil. Alright, so here's conjugate. Oh no, we need to do approaches 0. My bad again, I did it again. Alright, there we go. Square root of x plus 1 minus 1 over x. So that, let's do the conjugate, times the square root of x plus 1 plus 2 over square root of x plus 1 plus 2. Right? So now, multiply it out. So this would be x plus 1, right? And then minus 4 over just x times square root of x plus 1 plus 2. Right? So you have this. Now, here's a problem. The x's don't cancel because we have that 1 minus 4. So you know what we're going to do? We're going to fix the problem. We're going to turn that square root of x plus 1 on the top to square root of x plus 4. Alright, that's okay with you? I hope you don't get mad. But yeah, let's do that. So this would be x plus 4. X plus 4. Right? Just check me on everything like that. X plus 4, x plus 4. Now, there we go. So now you see the 4's cancel and the x cancels, right? Boom, 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 boom. So the limit as x approaches 0 of 1 over square root of x plus 4 plus 2. Now it works. You see that? Plug in the 0, you get square root of 4, which is 2 plus 2, which is just 4. So it'll be 1 over 4, right? I'll write it out just in case you don't see it. So this would be limit as x approaches 0, square root of 4 plus 2, right? I just plugged in 0 for x, and I have that. So square root of 4, you know, is 2, so it'll be 1 over 4. Equals 1 over 4. Make sense? Right? 1 over 4. Sorry about that. Okay. Now let's do another one. Let's do the integral of x squared sine x dx. Now we're getting into Calc 2. So if you're in Calc 1, you don't have to worry about this. It's good info. So here's the problem, right? What we're going to do is we're going to do what's called integration by parts. So I'll show you. It's really easy. U equals x squared. This is substitution right here. U equals x squared, and then du equals 2x dx. Right? We just took the derivative, and so that'd be 2x, and then just put dx next to it. And then do dv equals sine x dx. And that just means take the integral of this. So what's the integral of sine? Well, you know the derivative of sine is cosine, so it has to be negative cosine. So v is equal to negative cosine x. You don't need to put the plus c because, you know, you don't have to. Your teacher won't get you for that. Now you want to put this equal to this. Well, you know what I mean. So that's equal to, now here's where you remember the formula, which is uv. So when you do this 1,000 times, you'll know it. Negative, so uv, so x squared with times cosine negative. So we negative x squared cosine x. Then minus the integral of v, which is negative cosine x, so that minus would make it a plus. So minus integral v du. So du is 2x dx, right? So 2x dx. So you should have this on your paper. Negative x squared cosine x plus, because remember we had a negative here. Negative, then the v was negative cosine, so made it a plus here. Remember that. And then du was just this part. The 2x cosine, 2x dx, that's the du. So now you do it again. U equals x, du equals dx, dv equals cosine x, v equals derivative of cosine is what? Negative sine. Good job. So the integral would just be sine. So you have this, right? Always when you have like this type of thing, the x squared sine x. If you have an x squared, make that as your u. If you make the sine as your u, you'll never be done with the problem. Because that means you'd have to integrate this x squared, which would make x to the third over 3x to the fourth, and it'll never end. When you have this, make x squared your u, always. Unless, if you don't, you won't be able to finish the problem, ever. Okay? So let's do this. This is equal to what? Negative x squared cosine x plus. So now we're doing we're doing integration by parts. So uv, so x sine x, right? Minus the integral of v, what's v sine x, and then du, which is just dx. So we should have this. Okay, now we just do the integral of sine x. You know that. And so write down the rest. You can notice this is a lot of writing. So integral of sine x is, well, what's the derivative of sine? It's cosine, right? So the integral is opposite, so it would be negative cosine. So make that a plus, cosine x plus c, right? I know I'm going fast, but you got to be this fast if you want to be good at this. So derivative of sine is cosine. Integral of sine is just negative cosine. Negatives make a plus, plus c, you're done. So let's do another problem. This is like, I'd say this is a Calc 2 problem. So you have integral from 0 to 2 of integral from 1 to 1. Alright, I got a double integral. You're going to see it soon. And I have x squared, and I have y. And I have dy dx. This is Calc 2. I know we're going all over the place, but you know, if you if you want to review, this is good. So it's integral 0 to 2, 1 to 1, x squared y dy dx. What we're going to do here is, because we have all numbers here, we're going to break this. We're allowed to do that because it's all numbers, no variables here. So let's break this. What I mean by that is we're going to multiply this by this. I'll show you. So integral from 0 to 2, in parentheses, that's with the dx, because the dx was last, so you have x squared dx times integral is 1 to 1, y dy. You're allowed to do this. You want to do this, actually. When you have bounds that are just numbers, you can do this. Okay, you want to do that. It's much faster. So then just integrate, you know? So this would be, what? X to the third over 3 from 0 to 2 times y squared over 2 from 1 to 1, right? If you don't remember definite integrals, this is what we're doing right now. So this is a good warm-up. So then plug in the top. So the 2 goes in for the x, so 2 to the third is 8. So that'd be 8 over 3 minus, plug in the 0, just get 0, times y squared with 1 in is just 1/2 minus 1/2. So that's 0. Guess what our answer is? I know you're like, why'd you make me do that? Why'd you make me do that? You know it's 0. Yep, you got it. But that's just a warm-up. Let's do something harder now. Let's do the integral from 0 to 1 of the integral from 0 to x. All right, and then we're going to have y, and then we're going to have x, and we're going to have dy dx. All right, and then we'll come